Good evening to all of you. I'm actually, I'm very thankful to the Chola Foundation for giving me this opportunity to share some of my research findings with you all. Thank you, one and all. Actually, what I'm going to present today is the simple work presented by one of my PhD scholars recently in 2017 for his Viva Voce examination. So that work, I'm going to present. And what are the difficulties, I have encountered, that also I'm going to share. If any doubts are there, just please ask me then and there. The carbazole alkaloids, I think you know the structure of carbazoles. So carbazole is actually pyrrole molecule, nitrogen heterocyclic 5-member ring. If it is fused, so one side benzene, it's called indole. Then indole, linearly fused benzene, that is 2,3A fused benzo indole is called carbazole. Actually, the carbazole alkaloid, has been isolated from Muraya Koingi. That is, in Tamil it's called Karvepale, Karvepale. 150 carbazoles have been isolated from Muraya Koingi. And among the 150 carbazole alkaloids, the pyridocarbazoles, actually, that is known as ellipticine and olivacine. These two are pyridine derivatives of simple carbazoles. They are known for their anti-cancer properties. Actually, so far, I have produced 23 PhDs. So 14 PhDs, they have worked on carbazole alkaloids. And then 7 members worked on quinoline alkaloids. And the rest of the two students worked on nitrogen and oxygen heterocyclic compounds. First back side. This is a synthesis and the biological evaluation of novel carbazoles. So actually, the contents have been divided into the 5 chapters. The first chapter, the introduction, the synthetic utility of 2,3,4,9 tetrahydrocarbazoles, the synthesis of heteroanylated carbazoles. Then chapter 3, regioselective synthesis and stereochemical structure of dispyrocarbazole hybrids via 1,3-dipolar cycloaddition reactions. Then chapter 4, a novel synthesis of aryl and heteroaryl annulated carbazoles, newly synthesized pyrido, benzoate, and spiroxindole indolin benzoate carbazoles. Then chapter 5, synthetic utility of 3-amino 9-ethyl carbazole, synthesis of pyrido 3,2B carbazoles and its related compounds. Introduction. The carbazole derivatives are privileged class of nitrogen containing pi conjugated heterocycles. Many natural products and drug molecules with the carbazole moiety exhibit a wide range of biological, pharmacological, and photophysical properties. Aryl, heteroaryl annulated carbazoles are frequently encountered in natural products and pharmaceutics, attributable to their structural implications for biological systems. MCRs, that is multi-component reactions, play an important role in modern synthetic organic chemistry by virtue of their convergence, easy of execution, productivity, and selectivity. Carcinogenesis is a highly complex and multifaceted process characterized by metathesis, inhibition of apoptotic pathways, and uncontrolled cell proliferation, and which leads to the development of cancer. In light of these findings, here we derived some methods to derive heteroanylated carbazole alkaloids. Now, here some of the biologically active carbazole alkaloids are given below. As I told the pyridocarbazoles, the pyridine, here the ring fusion is 1, 2, 3, 4, 3B pseudocarbazole. This is known as ellipticine. Oleucine, both are dimethyl derivatives of pseudocarbazoles. And some of the modified the carbazole alkaloids are given below. Here, the green is pyranocarbazole. Actually, naturally occurring carbazole having a pyran structure. The fusion is 1, 2, 3. This is known as a 2,3A fused carbazoles. So whatever isolated, I told 150 carbazoles have been isolated. They're all having oxygen function at second position with respect to the carbazoles. But in our case, as I told I produced nearly 14 PhDs in carbazole alkaloids. We have synthesized many compounds where the oxygen function is present in the first position. So far, the type of compounds have not been isolated. But in near future, I'm sure we are going to isolate such type of compounds in Muria Koengi. And also one more thing I want to tell you, there is an isomer called mupamine. The mupamine is having the oxygen function at the first position with respect to the carbazole. So that means there is a chance to exist such type of a starting material where that can be used as a syntha to derive the pyrano 2,3A carbazole derivatives. Yeah, to this pseudocarbazoles, the synthan is aminocarbazole. Actually, in the initial stages in our research, we have tried to synthesize aminocarbazoles directly from 1-oxo-tetrahydrocarbazoles by simple, nitration and reduction methods. But when we did this reaction, we have isolated many new compounds other than the aminocarbazoles. But these are all the very simple compounds. But really, some 15 to 20 reactions we have tried, but we have not succeeded in isolating the aminocarbazoles. But we are getting aminocarbazole, but within minutes, it will become charred, So we are unable to crystallize the compounds or doing the column cryptography and all. Sorry, excuse me. So finally, what we did, we have prepared the pseudocarbazoles by classical methods. That is nothing but just you have taken 1-oxo-tetrahydrocarbazoles, then it was reduced to the 1-hydroxycarbazole, then it was formulated by Wills-Meyer-Hawk conditions. There are several methods, for formulations. Then we constructed alpha pyrones, that is, indolo coumarins. Then it is reacted with amines. Just, we got indolo coumarins. Then finally, these coumarins were treated with ammonia. Then the O bond, the heterocyclic O is replaced by NH. Finally, the POCLT treatment, we got pseudocarbazoles. Dehalogenation, we got pseudocarbazoles. So these are all the methods, and the preparation of this 1-oxo-tetrahydrocarbazole, it involves simple YAP-Klingman reaction. Actually, it is given in very much book and standard books. YAP-Klingman reaction. So YAP-Klingman reaction is diazotized aniline derivatives on unification with the beta keto aldehydes, will get hydrozones. Hydrozones on acid catalyzed cyclization will be getting 1-oxo-tetrahydrocarbazoles. Actually, This here we prepared a lot of compounds. Different toluidines, we have used different anisidines and different anthranilic acid. So if we use this type of amines, so we'll have different substituted groups in airing. But no, in the case of one of the tetrahydrocarbazoles, if you take the para substituted amino compounds, we'll be getting 7 substituted compound. Suppose if you take meta substituted, we'll get 5 and 7 substituted compounds. If ortho substituted compound, if you take, you'll get 8 substituted 1-oxo tetrahydrocarbazoles. These compounds are fully exploited, in synthesis of various compounds. And no, when we use alpha tetralone instead of cyclohexanone, alpha tetralone was formulated, and then when we did the cyclization, we got 1-oxo compound, 1-oxo benzo substituted carbazoles. But when it was subjected to various reactions, it did not give any product. Later we found that the one of the methyl group is getting oxidized to C double bond O. Actually, this paper, we have published in Tetrahedron Letters in 2014. Then this 1-oxo tetrahydrocarbazoles was reduced to the corresponding 1-hydroxycarbazole. Then it was subjected to prepare biogenetically possible. As I told you, there is a chance to isolate a compound where the oxygen function will be present in first position. So we prepared nearly 100 compounds where the oxygen function is present in the first position. We prepared, actually, we can give the nomenclature: indoloflavonoids, indolocoumarins, indolochromones, indolochromonones, flavonones. Like that, we have prepared all type of compounds. But as I told you, I am sure that this type of compounds will be isolated in near future. Okay, in the present case, it is a very simple work. The one of my PhD scholar, he has presented this work, for his viva voce examination. He has published 7 papers in this thesis. So this is a very simple work. Just I will explain, one by one reaction, and I will explain, the characterization of this compound by IR, NMR, C13, and actually in most of the cases we have established the structures based on single crystal structures. So actually this part of this work, has been published in the New Journal of Chemistry, 2017. Here synthetic utility of 2,3,4,9 tetrahydrocarbazoles, synthesis of heteroanylated carbazoles. An attempted synthesis of pyranocarbazole, synthesis, photophysical properties, and the DFT analysis of highly substituted pyridocarbazoles based push-pull chromophores. Okay. The multi-component reaction. One of the tetrahydrocarbazole and reacted with melanonitride, presence of aryl aldehydes, in presence of sodium methoxide and methanol. Actually, we expected this product. The amino compound. But the obtained product is the pyrido substituted. That is pyrido substituted 2,3-S pyridocarbazole derivatives. So optimization of the reaction conditions. Here, we have used different bases: triethylamine, DABCO, that is the diazobicyclooctane, sodium hydroxide, potassium hydroxide, sodium methoxide, piperidine, etc. Here, the sodium ethoxide methanol at 80 degrees centigrade for 3 hours the 85% we got the pseudocarbazoles. Actually, as I told you, this structure has been established based on the single crystal structure. The in this compound, the characteristic peaks for Steno group, 2217 reciprocal centimeter, NH 3337 reciprocal centimeter, for C double bond N 1556 reciprocal centimeter. From NMR spectrum, if you take, there are two methylene protons. It's coming at 2.96 to 2.91, 2.87 to 2.82 as two multipliers encountered for the four methylene protons. And the C2 OCH3 proton is coming as a singlet at 4.18. And then the C11H is coming as a singlet at 8.65. Then the number of carbons, will be confirmed from its C30 NMR spectrum. This reaction, has been generalized. We have synthesized 17 compounds. So in the most of the cases, we got the quantitative yield, and all the compounds, maximum compounds, are confirmed from the spectral details and single crystal structures. So here it is the reaction mechanism. So aryl aldehyde dye, that is melanonitrate, and non-acyl condensation in presence of base gives a non-acyl adduct 1, and the carbanion generated from 1-oxo tetrahydrocarbazole on 1,4-Michael addition with the adduct, it gives the structure 3, intermediate 3, then aminocarbazoles. Here, this is on a prototropic shift. This on prototropic shift on cyclization, intramolecular cyclization. One can expect, this type of product. But somehow, we didn't get this product. But here, what happens, that methanol is acting as a reactant, co-reactant. It attacks C double bond NH, methanol addition followed by cyclization, dehydration, and aerial oxidation. So we are getting the possible, the observed product. So since we didn't get this product, actually we obtained the same product by using a different condition. That is, instead of methanol, if you use piperidine, we are getting this product. Okay, now anyway, I'm going to explain about this work. But here, the one more evidence for this proposed mechanism is correct. That is, when the reaction has been conducted in ethanol derivative, we are getting 2 OET derivative of the pseudocarbazoles. So this strengthens our proposed mechanism is correct. Yeah. No, these are all the photo. Actually, I'm very sound in synthetic organic chemistry. These are all the applications, the photophysical properties. To evaluate the solvatochromic effect of synthesized compounds in absorption emission spectra. They use a series of solvents like DCM, chloroform, methanol, and DMF with the different polarities. These are all the derivatives. As I told you, the previous all derivatives. These are all the lambda absorption. So here the absorption left and the fluorescence right spectra of 5A to D in DCM. It is observed from the photophysical studies that the compounds exhibit absorption maxima, lambda in the UV visible region 390 to 407 nanometers, and the emission spectra, emission maxima, yellow to red region 464 to 504 nanometers. A change of solvents from DMF to DCM resulted in a little blue shift 2 to 9 nanometers of the absorption maximum. The maximal emission peaks of compounds 5A to Q are mainly located at 464 to 504 nanometers, with Stokes shift ranging from 2,931 to 4,729 reciprocal centimeter. The emission spectra shifts to higher wavelengths with increasing solvent polarity, bathochromic shift from DCM to DMF. Here, it is observed that the fluorescence spectra showed a significant solvatochromism. An increase in the solvent polarity led to increase in the Stokes shifts of the absorption and emissions maximum. This finding supports a highly polarized excited singlet state generated by the intramolecular charge transfer from the donor carbazole moiety to the acceptor cyno group in carbazole derivative within the molecule. The thiophene group induces more redshift in both absorption and emission spectra and exhibited highest quantum yield value. The relative fluorescence quantum yield of the pyrido-2,3A carbazoles was calculated using the following equation. The quantum yield changed from 0.48 to 0.65 for compound 5H with increasing solvent polarity. So this is fluorescence lifetime measurements. The fluorescence lifetime tau is an intrinsic property of a fluorophore. The lifetime are relatively long from 7.14 to 9.13 nanosecond. Most decay curves can be well fitted with a single exponential value range from 0.96 to 1.10. The fluorescent lifetime analysis of pyrido-2,3A carbazoles. So DFT calculations. In order to understand the electronic properties of synthesized compounds, density functional theory calculations were carried out using Gaussian 09 program. Molecular structures were optimized through M062X for 6.31 dimensional level of the theory. So here, the compounds, the FMO energy levels of compounds 5A, 5D, 5H, 5J, and 5K, calculated using the level theory. The comparison of HOMO and LUMO values of energy gap for selective compounds are visualized here. The compound 5H bearing thiophene moiety exhibited lowest energy gap value at 5.469 volts compared to other compounds due to other higher overlapping of HOMO-LUMO orbitals of displayed high conducting property. This compound also showed bathochromic shift in emission spectra and high fluorescence quantum yield. Next, our synthetic program is synthesis of 2-amino-4 aryl heteroaryl 5,6-dihydro 11H pyrano 2,3A carbazole, 3 carbonitrates. Actually, this part of the work, we have published in synthetic communication. Prompted by the encouraging importance of pyrano carbazoles, we embark on the synthesis of 2-amino-4 aryl heteroaryl 5,6-dihydro 11H pyrano 2,3A carbazole, 3 carbonitrates. Here, as I told you, this is 1, 2, 3, 2, 3A pyrano carbazoles. Same conditions, but actually now we have changed, the solvent to the DMF. Instead of sodium, that is the base is piperidine. So you use different aldehydes. Here the reaction conditions, different bases we have employed. The piperidine, DMF, 3 hours at 120 degrees centigrade, 87% yield we got. Here, this compound, this compound was established based, the structure was established based on IR, NMR, and C30. The FTIR, the NH, is coming, the amino group coming, the symmetry and asymmetric stretchings of NH2 group, the 3,365 and the 3,414 reciprocal centimeter. This is the NH is coming at 3,272 reciprocal centimeter. Nitrile group is coming at 2,207 reciprocal centimeter. This is the NMR spectrum. Actually, the 11 C11 NH is coming as a broad singlet at 9.24. The NH2 peak is coming at 5.13 as singlet, and these two methylene protons coming at 2.84 to 2.80, 2.68 to 2.64 as two multiplets, and the methyl proton at the 6th position with respect to the carbazole is coming at 2.44 as a singlet. The number of carbon atoms established based on its C13 NMR spectrum. So here also, the scope of the various substituted pyrano 2,3A carbazole derivatives. Actually, we prepared 12 pyrano 2,3A carbazoles having amino group at 2nd position, nitrile group at 3rd position. Here the mechanism is aryl aldehyde with melonitrile. Piperidine, we are getting melonitrile, that is intermediate one. The intermediate one is getting attacked by the carbanion and Michael addition. Gives ketamine hydrochloride. The ketamine hydrochloride is intramolecular cyclization, gives directly the product. This simple mechanism. Then next is synthesis of naphtho-diazepino carbazoles. Actually, this is simple work. Actually, you prepare some 5-6 compounds. One of the tetrahydrocarbazoles reacted with 3-amino 2-naphthoic acid in presence of polyphosphoric acid at 120 degrees centigrade. So we got diazepino carbazoles. And actually, just I want to tell in a small reaction, this 1-nitrocarbazole has been employed as a starting material to prepare pyrazinocarbazoles, T21JK carbazoles. Here, we introduced the pyrazine group across N and C1 group. Here, because in the whatever procedures available in the literature, they introduced the compound from C1 position. But if you do the C alkylation, we are getting, the N as well as C2 alkylated product. To avoid this, directly, we have introduced the nitrile group here by reacting with one of the tetrahydrocarbazoles with acrylonitrile. Then it was reduced to amino group. Finally, we got pyrazinocarbazoles. Actually, that was our original work. So followed that, we have prepared this type of diazepino 321JK carbazoles. So here also these compounds, were established. These are very simple compounds. C double bond N, and this is 1659 reciprocal centimeter. The methylene protons at 3.07 to 3.05. And another methylene protons at 2.28 to 2.35. These are important peak. This is the number of carbon atoms. Start from the C13 NMR spectrum. Next one is synthesis of isoxazole, pyrido, and pyrimido carbazoles using 2,3' bromo, 4' methoxy, benzylidine, 2,3,4,9 tetrahydrocarbazole as synthol. Here also, just so here, when the one of the tetrahydrocarbazoles were reacted with different aryl aldehydes in presence of alcoholic KOH, room temperature, we are getting, the benzylidine derivatives. But here, in this case also, we have used, different aryl aldehydes. If suppose if we use, diethoxy, the starting material itself, is found to have anti-cancer properties. Actually, this paper we have published in Bioorganic Chemistry in 2014 by Lena, actually one of my PhD scholars. Suppose if you use, bromo compound, simple bromo compound, then one more scholar, by name Yamuna, he has published that work in European Journal of Chemistry, European Journal of Medicinal Chemistry. So if suppose the combination of both bromine and methoxy group, it may play a vital role in biological properties of organic compounds. So in that context, we have prepared, this type of aryldine derivatives by using 3' bromo, 4' methoxy benzaldehyde. So we got this type of aryldine derivative. These compounds are established based on spectral details. Spectral details, that's very simple compounds, that it's IR, NMR, C13, just to establish. Just, as expected, these compounds were found to have very good anti-cancer properties. This paper has been published in European Journal of Medicinal Chemistry. The synthesis of 3' bromo, 4' methoxyphenate, 4' dihydro, 10H isoxazole, 3,4-A carbazole. So this is isoxazole. There is 1, 2, 3, 4, 3,4-A isoxazole carbazoles. Simple reaction, this is when reacted with hydroxylamine hydrochloride in pyridine, we are getting isoxazole carbazoles. So this method, this reaction was generalized. We prepared a number of compounds and established the structure based on spectral details. So here, that the two methyl protons coming as a two multiplets. So one is that is a 2.96 to 2.88 for the methyl protons. C4' OCS3 is coming as a singlet that C13 and carbon spectrum 56.3. And this aryldine derivative reacted with that is malonitrile, sodium base in benzene, ethanol. You are getting a 2-ethoxy cyano-substituted compound. This also, we have generalized on many compounds, and the structures were established based on details. Here, the cyano group, is coming as 22 like 18. C double bond is 15, 55 reciprocal centimeter. NH is coming as a 3,335 reciprocal centimeter. NMR spectrum for 11 N11H is a broad singlet. Then CS2 CS3 is coming as a 2 quartet and triplet with a J is equal to 20. So 3.96 singlet 3 4 prime goes CS3. The methylene protons are known as 2.97 to 2.87. So number of carbon atoms established based on C13 mass spectrum. Here the structure of 12D anhydrous with the ellipsoids depicted at this 5.50% probability level. Atomic labeling show hydrogen atoms are omitted and only one position of the disordered water oxygen is shown for clarity, O5. Similarly, in this structure 12D, this is hydrated, this is anhydrous form. Then synthesis of 2 amino, 4, 3 prime bromo, 4 prime methoxyphenyl, 11H, pyrimido 43A, carbazoles. So here, this pyrimidine ring. The pyrimidine ring is a 1, 2, 3, 4, 5A. 4, 5A pyrimido carbazoles. Now here, a typical reaction, guanidine nitrate in presence of sodium hydride base in benzene. When it was reacted, we got this product. But here the pyrimido carbazoles, we found that it is getting aromatized. The methylene protons, getting aromatized. Actually, this is maybe due to the formation of more stable compound. Here, this is a single diagram structure of compound number 13D. So asymmetric symmetric settings of amino group at 33, 28 and 34.05, and NH is coming at 32.12. So 1570 C double bond N, 1540 C double bond N. Yeah. The proton number spectrum, 9.90 broad singlet, 11H. So 8.12, 7.06, 9 aromatic protons. And the amino protons coming as a broad singlet, the singlet 5.57. And the OCS3 protons coming as a singlet at 4. They are the typical, the OCS3 carbon is coming at 56.4 in its C13 NMR spectrum. So here, this is a mechanism. The synthon 10 starting material formed by the Claisen-Schmidt condensation of aromatic aldehyde and 1-oxo tetrahydrocarbazole. In presence of that is guanidine nitrate. This on amino group of guanidine nitrate react with 10 to upward shift base intermediate 1. The intermediate 1 on 1,6 Michael addition cyclization followed by phototropic shift gives intermediate 2. This intermediate 2 and phototropic shift and intramolecular cyclization, aerial oxidation. Intramolecular cyclization come aerial oxidation. We are getting this product. This is actually very simple, the mechanism. Here, the important thing, we observed is it is getting aromatized, aerial oxidation. Even, if you conduct this experiment in nitrogen atmosphere, you are getting aromatized product. So in vitro cytotoxicity, actually, 2 cancer cells, we have tried MCF7A and A 549. So here the compound 11B is comparable with the standard drug, that is a cisplatin. 21 plus or minus 1.7, 28 plus or minus 1.4. And the compound number 13B and 13C are also found to be very active, So here, cytotoxic effect of the compounds 11B and 13B on the viability of MCF7 and A549 cell lines. Structure activity relationship. Here, just see this hetero, that is pyrimidine ring is constant. By changing, different substituents across carbazole, the role of substituents in increasing the efficacy of cytotoxicity. That means a halo group will increase its property just by changing, different heterocyclic group. That is here simple pyridine, here isoxazole group, here pyrimidine. Comparison isocyclic activity of annulated heterocyclic compounds. Here, the compound number 13A2D found to be highly active towards the cancer cells. So these are all, some data, obtained from its the morphometric analysis of the treated MCF7 and A549 cells. Conclusion. The first part of this chapter, the synthesis of structurally diverse and fluorescent pyrido-2,3A carbazoles via pseudo multi-component one-part reaction was described. The synthesized compounds were subjected to photophysical studies and DFT theoretical evaluation, which show that charge transfer occurs within the molecule. And due to their strong fluorescent properties, these compounds are promising candidates for fluorescent probes and fluorescent makers. In the second part of this chapter, we have established fast and efficient routes for the synthesis of pyrano-2,3A carbazoles by multi-component reaction of 2,3,4,9 tetrahydrocarbazolone with malonitrile and aromatic heteroaromatic aldehydes. The synthesis of novel hexahydro 10-oxo-benzo diazepino 3,2,1-JK carbazoles were also prepared from 1-oxo tetrahydrocarbazoles and naphthalate acid amino derivatives. Finally, this chapter describes the synthesis of newly heterocyclic isoxazole, pyrido, and pyridocarbazoles from the easily accessible 2,3'-bromo, 4'-methoxybenzidine, 2,3,4,9 tetrahydrocarbazole by cyclocondensation with appropriate reactants is a hydroxylamine hydrochloride, malonitrile, and guanidine nitrate. The compounds have been screened for in vitro anti-tumor activity against MCF7 and A549 by MTT assay and apoptotic morphological changes in MCF7 and A549 cells are visualized using fluorescent microscopic technique. The structure activity relationship studies revealed that the compound bearing the primitive moiety and the electron withdrawing chloro group in the carbazole displayed excellent cytotoxic activity. Just actually from this chapter, we published 3 papers. One is the NJC, New Journal of Chemistry, that is synthesis, photophysical properties, and DFT analysis of highly substituted pyrido carbazole based push-pull chromophores. And then the other second paper is design and synthesis of pyrano-2,3A carbazoles by multi-component reaction. And the third paper is European Journal of Medicinal Chemistry. There's a very big paper, actually it has 13 pages. Synthesis of heteroannulated isoxazole, pyrido and pyrimido carbazoles screened for in vitro anti-tumor activity and the structure activity relationships. A novel 2-amino 4, 3'-bromo, 4'-methoxyphenol, 8-chloro, 11H, pyrimido 4,5A carbazole as an anti-tumor agent. Actually, the chloro group, at the 8th position is found to be a very good anti-cancer agent. Yeah, the third chapter, is regioselective synthesis and the stereochemical structure of dispyrocarbazole hybrids via 1,3 dipolar cyclooxygen reactions. Actually, we have published a number of papers on the effective synthesis of carbazoles and its spiro derivatives by palladium mediated intramolecular reaction, multi-component reactions, and 1,3 dipolar cyclooxygen reactions. Actually, we have published this type of work in 3 tetrahedral letters papers and the Journal of Heterocyclic Chemistry, etc. So actually, apart from that, here we have prepared some more new compounds. This, I'm going to present in this chapter. That is a spiro heterocyclic skeletons. Here, one more thing, the chemistry of azomethane lights has gained significant in recent years as it serves as an important route for the construction of nitrogen containing 5-membered heterocycles. Here, the spiro heterocyclic skeletons containing 1 carbon atom common to 2 rings not only constitute subunits in numerous alkaloids, but are also templates for drug discovery. Functionalized pyrrolothiazoles, pyrrolidine, and oxindole alkaloids constitute a class of compounds with significant biological activities. Breast cancer and lung cancer are the 2 most diagnosed malignant tumors worldwide. Hybrid drugs design has emerged as a premier tool for the discovery of innovative anti-cancer therapy that can potentially overcome most of the drawbacks encountered when using conventional anti-cancer. Herein, we report a regio and stereo selective 1,3 dipolar cycloaddition method for the synthesis of a novel class of dispyro heterocyclic structure comprising pyrrolothiazole and pyrrolooxindole moiety. Here also, just the synthesis of 2-arylidine heteroarylidine 2,3,4,9 tetrahydrocarbazoles. So we use a different aryl aldehydes in KOH treatment in room temperature. We got the arylidine derivatives. Actually, this paper, we have published in the European Journal of Medicinal Chemistry, 2018. Yeah, these compounds, were established based on its IR, NMR, and C30. The carbyl group, it's coming at 1644 decibel per centimeter, NH at 3,290 decibel per centimeter. There are 2 methyl protons, at 3.05 to 3.03, 3.02 to 3. That is 2 methyl protons. And the C9H is coming as a broad singlet 11.64. And the C6CH3 is coming as a singlet at 2.50. Number of carbon atoms were established based on its C30 and NMR spectrum. Here, reaction of 2-arylidine, heteroarylidine 2,3,4,9 tetrahydrocarbazole with thiaproline and isatine. So here, thiaproline and isatine. So one of the arylidine derivative, when it was reacted with the carbazole, reflecting 1,4-dioxane methanol, afforded a new class of dispyro substituted carbazole compound 6-methyl 4'-phenate 3,4-dihydro dispyro carbazole 2,3' thiapyrazoline 2'3" undo 9H 1 2'' dione 6A compound rather than this compound 7. Here actually the other possible structure is ruled out, based on actually the reaction mechanism and also based on the spectral The other possible structure has been ruled out over the first structure. Here, just the FTIR spectrum 3318 reciprocal centimeter, that is indoor carbazole NH. Carbonyls coming at 1705, 1624, and C30 NMR spectrum is coming, as a 10.13 as a broad singlet for N9H, 9.85 broad singlet for N1'H, and the 4.53 doublet, that is the C4'H, 3.44, 3.31, two doublets with the JH you could jump, that's 6.40 hertz, 2.15 for C6CSC. Yeah. Here, the number of carbon atoms, established based on its C30 NMR spectrum. This is art of view of compound 6A. Here, this is, actually in detail, about the C30, that is NMR data. Here, actually, this is CH2 protons, coming as a geminal coupling, the 6.4 hertz. Geminal H. These two H's also 2.82 multiplet, 2.45 multiplet. These two protons. This proton is coming at as a doublet 10 hertz. So, if the other possible structure means here it is coming as a multiplet, there it is supposed to be the singlet. Now, if you see the other possible structure, here this H is coming, should be coming as a singlet, because the neighboring carbons will not have any hydrogens. So you are supposed to get a singlet, but in this case, in our case, we are getting the one is a doublet because of the neighboring proton. See here, this proton is coming as multiplet. So like that. So based on spectral details, we establish the structure, and single crystal structure also gives the correct picture about the structure. So we have prepared 9 compounds. The scope of various substituted pyrrolothiazole, carbazole derivatives. So 9 compounds we have prepared. In all the cases, we got the first product, not the second one. The next series of experiments, we examined the 1,3 dipolar cycloaddition reaction of azomethane lights generated in situ via decarboxylative condensation of thiapoline 4 and acinaphthaquinone 8 to 2-benzylene derivative. Here also just see the structure is ruled out based on the structure. Substituted carbazole compound 6-methyl 4'phenyl 3,4 dihydro acinaphthalene 2', 3', thiapyrrolazine 2' carbazole 9 1 1' diol 9A. Here just see that carbonyl is coming as a singlet at the 3,301 reciprocal centimeter. Then the carbonyl groups 1727 and 1639, and NMR speaks it's coming at 3.4943 3.47 as the geminal couplings. Here 4.83 doublet C4'H, J equal 10.40 H, 7.872 4.97 multiplied 15 aromatic protons, 8.70 broad singlet for C9 N9H, 2.33 singlet C6 CH3. So this is the art view of the compound 9C. So here this compound, as I told you, here this proton is coming as doublet 10 hertz. This proton is coming as multiplet 1H. Here the geminal proton, that is 3.59, 3.47 to 2 doublets with the geminal coupling 6.4 hertz. The CSC is coming as a simulated 2.23. 6.88, that this carbon atom is coming as a singlet. So totally we have prepared 5 compounds. Here also, we have not encountered the abnormal compound. Just we got, the expected product. Then, encouraged by the success of our reactions, we have extended this protocol to other azomethylide, which formed in situ through decarboxylative condensation of isatide 5 with benzylamine under similar conditions to furnish the respective diisopropyl pyrrolidine oxindole derivatives. There is 4' arylidine hetero.
Sir, your voice is not audible.
Hello, voice is not clear.
Now it is clear.
Is it okay now?
Yes, sir. It's clear.
Yeah, just here. This,
Is it okay?
Yes.
Okay.
yeah, this compound, was established.
Sir, he has muted. Sir, voice is not audible. Yeah.
It's not audible.
Now it is audible.
My voice. I'll just 1 minute. I'll get back to you. Okay. Just I'll take a break and I'll correct it and come back.
Sorry for the interruption.
Is it audible now?
Yes, sir.
2 minutes. We are joining.
Participant, sorry for the interruption.
Is it okay now?
Yes, sir.
Thank you.
Just, as I told you, these compounds, their structures were established based on spectral details. Actually, these are all, it's given here as usual, it is, if you see the mechanism here, the C30 NMR spectrum of 13A, here, as I told you, this is coming as a doublet, 4.69, then 10 hertz. This RTF of compound 13C. So we synthesize it, by this protocol 13 compounds. Here, the mechanism is isatide and dioxide methanol, benzylamine, azomethylide 12A is generated. Azomethylide. The nucleophilic carbon 12A, the nucleophilic carbon attacks beta carbon of 2-arylidine 1-oxo tetrahydrocarbazole. 1,3 dipolar cycloaddition with electron deficient beta carbon atom. Beta means to this carbo group, this alpha beta. This nucleophilic carbon attacks beta carbon of 1-oxo tetrahydrocarbazole. There is nothing but a dipolarified to offer cycloadduct 30. So here, if suppose path A is more favorable than path B due to secondary orbital interaction. Now, if you see the structure, molecular structure, so this is going through the unstable intermediate. That's why we are getting the first product. So in vitro cytotoxic activity, here compound number 13 DEF is as a comparable with the standard compound cisplatin. In vitro cycle, that is MCF-C7, MCF-7A 549 cancer cells, breast cancer cell and lung cancer. Here, cytotoxic effect of the compounds 13E and 13D on the viability of MCF7A 549 cell lines. Now here, structure activity relationship. Now here, the compounds 13G to the HI having methoxy substituents on the parallel ring showed moderate anti-cancer activities. Then the compounds bearing electron withdrawing chloro group in the carbazole ring enhanced the cytotoxic activity more than the electron donating methyl group. So here the heterocyclic group is constant. This is the morphometric analysis of treated MCF7 A549 cells. So conclusion, I think I will tell the next chapter, last chapter. This part of the work, we have published in European Journal of Medicinal Chemistry. That is a regio and stereo selective synthesis of spiroxindole pyrrolocarbazole hybrids via 1,3 dipolar cycloaddition reactions, cytotoxic activity and SAR studies. And the other part of the work, published in Chemistry Select, regio selective synthesis of carbazole grafted spirothiopyrozoline derivatives via 1,3 dipolar cycloaddition strategy. Chapter 4. Chapter 4, the novel synthesis of aryl and heteroaryl annulated carbazoles, newly synthesized pyrido, benzo, and spiro oxindolone benzo A carbazoles. So here also this introduction. Here, we have derived these compounds by reacting it with melanonitrate. So here, for the synthesis of novel aryl and heteroaryl annulated carbazoles, first we attempted to obtain dicyanoethylene 2349 tetrahydrocarbazole by the condensation of 2349 tetrahydrocarbazole 1 with melanonitrate 2 and ammonium acetate 3 in the presence of kinetic amount of acetic acid in toluene. Following procedure, they found that in the literature. Actually, this we have prepared a number of compounds and we established the structure based on the structural details. This is all, C30 NMR spectrum. So here, then isochromino annulated compounds. This was again expected. In that context, we reacted this compound 4 with malonitrile and salicylaldehyde, but we got the other product observed product other than expected. The pyridocarbazoles. So we got again pyridocarbazoles. So here optimization of reaction conditions. When you use ethanol and triethylamine, 3 hours, 83% yield we got the product. And the reaction was found to be general in the use of this method with various substituted 1-dicyanomethyl 2349 tetrahydrocarbazoles. Here, IR spectrum 3379 reciprocal per OH, 3211 NH, 2228 for Sino group, C double bond N 1555. In the NMR spectrum, NMR spectrum, here the two methylene protons observed as two multiplets. The remaining protons, is coming as expected. The ortho diagram and the number of carbon atoms established from its C13 NMR spectrum. This is, the mechanism, proposed mechanism. So when it salicylaldehyde, triethylamine in ethanol, we are getting, the salicylaldehyde undergoes nonagonal type of condensation with malonitrile and give two possible isomers, 1 and 2. These two are the isomers, geometrical isomers. The geometrical isomers. Here, this one, where this group, is away from OH group. This in presence of base, the base abstracts a proton of 1-oxytetrahydrocarbazole. That is Michael addition. Actually, here I've given detailing. The cells undergoes nonagonal type condensation with malonitrile, give two possible isomers, 1 and 2. The carbanion intermediate from 4, carbanion intermediate 4, and 1-2 Michael addition. Intermediate 2 gives intermediate 3. Intermediate 3. This prototropic shift and prototropic shift followed by intramolecular cyclization. Intramolecular cyclization, get the intermediate 5. This on nucleophilic attack of ethoxide ion in base, nucleophilic attack. So we are getting the compound, the intermediate 6. The subsequent loss of malonitrile and hydrogen molecule furnishing the product. Just see for the expected product, the other isomer, cycloaddition reactions, and that is another isomer, simple cyclization will get 2 imino benzopyran. This arm are the same, pica addition reactions. So you'll be getting, this OH. Here you are getting tautomerization, hydrolysis, expected product, isochromino compound. But we are not getting this product. Instead of that, we got. So based on that, we have proposed this mechanism. Then an attempted synthesis of amino benzocarbazoles, using ionic liquids. So this, by using this starting material, aryl aldehydes, multi-component reactions. Actually, we expected this, but what we got is this. Multi-functionalized benzo A carbazoles. In attempt to anticipation to derive 2 amino tetrahydro benzocarbazoles, the 4 reacted with the 2 amino malonitrile are then in presence of ionic liquid. So this reaction also generalized, and reaction conditions were optimized. Room temperature 10 hours, 81 degrees, 81% yield. So here, 12 compounds we have synthesized. These compounds were established based on IR, NMR. So most of the compounds, established based on single crystal structures. Single crystal structures. Here, the mechanism is nonagonal condensation. Then the Carbanian attack, Michael 1,2 type of addition reactions in presence of here the compound number 3B on this Carbanian attacks C double bond NH dipole. So you are getting this type of expected product, actually dicyano expected product, but somehow immediately it seems it is unstable. Removal of HCN molecule gives the observed product. Actually, this compound, actually the reaction mechanism is going through the intermediate, that is the expected product. It seems the expected product is unstable. Immediately in situ, it is losing hydrogen cyanide. So we are getting highly functionalized benzo A carbazoles. So here ionic liquid plays an important role. Then attempted synthesis of amino spiroxindole benzo A carbazoles. Synthesis of amino spiroxindole benzo A carbazole. No, same thing, just the zatine, malonitrate. Here you are used a mild base, DABCO. DABCO is a diaza bicyclo octane. Diaza bicyclo, it's a mild base. So in that case, we have synthesis some of the compounds. So here this method has been extended, and we prepared a number of compounds. Here also the reaction conditions have been optimized. 83 DABCO, in ethanol, 83% yield, just 1 hour. Here the characterized by NMR spectrum and all, FTIR. See that these are all normal way. So just see here we synthesize some 12 compounds. In all the compounds, we got the expected product only. We didn't get the expected product. Observed product is this DABCO catalyzed reaction. The mechanism. Here just the DABCO for the removal of proton is on DABCO mediate nonagonal type of condensation is that it's intermediate 1. Intermediate 1. The Carbanian intermediate 2 on 1,4 Michael addition with the 1 provides the intermediate 3A. Stabilized through a tautomerization form. This is a tautomerization form. This is an intramolecular cyclization. Prototropic shift, you are getting the expected product. Conclusion of the now, actually, this paper, we have published in Chemistry Select. Novel synthesis of aryl, heteroaryl, annulated carbazoles, newly synthesized pyrido, benzo A, and spiro-ox indolin benzo A carbazoles. Chapter 5. No, I think I will go very fast. This. This compounds. Just here. This is a very simple. Reaction of 2, 3 amino. Actually, as I told when I started my research, I tried my level best, to prepare amino carbazoles, but we didn't succeed. So next, what we did, we have taken directly readily available amino carbazoles. that is 3 amino 9 N-ethyl carbazoles, and reacted with alpha aride 3-oxo propane nitride 3 aryl aldehydes, triethylamine DMF. So here, one can expect a mixture of the two products or either one of these two products. But here, what we got is linear product. This is actually, angular linear. Actually, what we got is linear product. FTIR spectrum of 5A. So similarly, some C13. The NMR spectrum and C30 NMR spectrum established the structure. So based on that, we prepared some 8 compounds. And the next reaction is in presence of benzaldehyde, methyl propionate in L-proline ethanol. Here also, we got, different, entirely different new product. So we didn't get these two products. So for this also generalized, and we proposed a mechanism. The Cauchy depth spectrum of this thing, we established the structure. So here, these two protons were found to be trans with a trans coupling of 15.6 Hertz. And this proton and this proton found to be trans 13.2 Hertz. 13.2 Hertz. So actually, this just see here, the reaction sequence initiated via the Michael addition only. Here, first Michael addition. Again, the 3 amino carbazole with splenic ester 6 resulting in the formation of tautomeric zwitter ion forms 1 and 2. 1 and 2 zwitter ions. Further Michael type of addition of intermediate 2 with a 6, followed by prototropic shift. You get stereoselective compound number 9. The same thing, just an attempted Michael addition reaction of 3 amino 9 ethyl carbazole with benzaldehyde, propiolate 6 in acetonitrate in the presence of catalytic amount of SbCl3. So here also we got the entirely different product. That's a pyrido-substituted compound. Pyrido-substituted carbazoles. So for this also we have generalized, and actually this paper recently only published in Chemistry Select. Here the reaction conditions are optimized. The SbCl3 10 moles, acetonitrate 5 hours, 67% yield. Here the mechanism is various Lewis acid catalysts we have employed. But here this is found to be SbCl3 is found to be very effective. These are all established based on spectral details. Here, so mechanism, just see that mechanism. The tautomeric zwitter ions forms 1 and 2 formed by the Michael addition reaction between 3 amino 9 ethyl carbazole 1 and acetylene carboxylate 6. The nucleophilic attack on the carbonyl carbon atom of the aryl aldehyde come prototropic shift on intermediate 2 affords intermediate 3. Subsequent Michael addition reaction intermediate 3 with acetylenic carboxylate yields dipolar tautomeric attack forms 4A 4B. 4A 4B. The 4A 4B which are under upon prototropic shift affords more stable enamine intermediate 5. Enamines. Then lone pair electrons on nitrogen initiated cyclization on intermediate 5, followed by elimination of proton, gives the final product 12. So here, the intermediate is stable enamine intermediate. Conclusion. So here, just see. Here the second chapter, 1 of the tetrahydrocarbazoles. We have prepared pyrano carbazoles, pyridocarbazoles, and diazepino derivatives, and isooxazole pyridocarbazoles. This we established in chapter 2. Chapter 3, that is, the diisopro spirohybrid compounds were synthesized in a regio or selective synthesis. This I think already explained. Chapter 4, the versatile synthetic utility of alpha-alpha dicyano olefins were presented. Highly substituted pyridocarbazoles, benzocarbazoles, and spiroindolene benzocarbazoles were synthesized. Structures of the compounds were confirmed stereospecifically, and single X-ray diffraction studies. A possible mechanism for the formation of products has been described. Chapter 5, highly substituted pyrido K2B carbazole derivatives derived from the reaction of 3-amino 9-ethyl carbazole with aryl heteroaryl aldehyde and alpha-aryl 3-oxo-propionitrile. An attempted synthesis of 3-carbomethoxy dihydropyridocarbazole isomers yielded 9'-methyl carbazole 3'-amino 2,4-di-carbomethoxy 1,3-butadiene. A catalyst-controlled divergent reaction of 3-amino 9-ethyl carbazole with aryl aldehyde and methyl propiolate resulted 9-ethyl carbazole 3-vial dihydropyridine 3'-5' dicarboxylate. A mechanistic relationship rationalization for the formation of the product has been described. Here actually a new class of compound we have derived. So we don't know the reason, but we didn't get the expected product. So thank you one and all.
Thank you. Thank you for listening to this excellent presentation. Thank you, Professor, for an excellent presentation of a part of your scholars' research work. We are all very much delighted with the casual presentation of an in-depth research by you and your team. Of course, one of the objectives of this series of sessions is to make the young students opt for the research as their career. I am sure your presentation has served this purpose. Thank you very much, sir, once again. I thank all the teachers and the students for listening to Professor's presentation. I am sure it is a real value for time for every one of you. Thank you once again for everyone who listened to this excellent presentation. I am very much delighted to have such a presentation, and I am very much proud of arranging this session also. Thank you once again. Now my request is I request everyone to prepare the feedback form. The link for the feedback form is given in the chat box. And another thing is, I request everyone to feel free to ask questions so that Professor can give you a right answer. Also, we will share the email ID and the WhatsApp number. You can share all those things. And if you find it difficult to speak now, you can put in the chat box also. We will take another 10 minutes or 15 minutes to answer all the questions. Thank you once again. Now let's go for the question and answer session.
Sir, I am Dr. Velmati from NIT Trichy.
Yes, madam.
Am I audible, sir? Okay.
Yes, you are very much audible.
Yes, sir. It's an excellent presentation. Thank you, Professor Rajendra Prasad, for in-depth work on spiroxoindoles as well as lot of heterocyclic compounds. Only I have one doubt in your chapter 2, where you have shown the intramolecular hydrogen bonding with your arylidine and then the carbonyl compound. Like if I'm right, slide number 27. There is a heterocyclic NH also. Did you find any hydrogen bonding between that NH and the C double bond O, because that is much more feasible rather than the arylidine hydrogen and then the carbonyl.
27, just to tell me, the 27?
Yes, sir. 27 or 26, maybe somewhere around that.
Okay. No, you are telling a scheme, madam. Scheme, Yeah.
Yeah, there you showed
yeah.
intramolecular hydrogen bonding.
Okay.
In your chapter 2, there was a carbonyl and then this carbazole NH is also there.
Okay, madam.
But you showed the arylidine hydrogen and then the carbonyl is forming a hydrogen bonded 5-membered ring. Whereas NH can also equally interact and form hydrogen bonding. So whether do you find that observation in your work?
No, madam. No. Actually, here we prepared a lot of compounds. As I told you, just this NH is not interfering in the cyclization reaction. When it is reacted with hydroxylamine hydrochloride, directly we are getting this product, hydroxylamine hydrochloride. This NH bond that is not participating actually in the reaction.
Generally, carbonyl and NH, they also.
NH is there, yeah, it is generally no, but in this case, in our case, it is not. It is not because we are using a pyridine base. We are using pyridine base. Okay, that will take care of that H. So immediately that C double bond O is getting attacked by the nucleophile NH2OH, role per electron on hydroxylamine hydrochloride. That NH2OH will come and attack. So actually the yield also very good under. Now we have used this compound as a starting material to prepare a lot of compounds.
Because chalcones is the fundamental unit for all your further studies.
Yeah.
Okay, sir. Thank you, sir. Lot of work.
Yeah, thank you, madam.
Any other questions, please?
Feedback link is provided in the chat box. Kindly fill up the feedback form. Any other questions from the participants?
This is Prabha.
Actually, one thing, just I want to tell you here that 1-oxo tetrahydrocarbazoles, 1-oxo tetrahydrocarbazoles. When we prepared hydroxylamine hydrochloride oxide, just we added 3 reagents: acetyl chloride, acetic anhydride, sodium acetate. Just we heated for 180 degrees for 3 hours. We got entirely a different product. We introduced a new 3 functional groups on carbazoles. So one is the NN diacetyl group, the other one is hydroxyl group, third one is acetyl group. And also there we have proposed a mechanism. And actually, one thing, madam, I want to tell, up to 2007, we used to prepare a number of compounds. After preparing, we used to publish, that's all. But after 2007 only, we just whatever compounds we synthesize, we try to propose mechanisms, and we got single crystal structures to ascertain the structures, and biological testing is also most of the compounds were found to have biological properties.
Yeah, recently we have also synthesized a set of spiroxo indoles, sir, which are having very good anti-diabetic activity. Recently, that paper got accepted in RSC Advances. So soon it will come. I will send you. We are also working on the similar field.
Okay. No, it seems spiro compounds are very effective. It seems.
Yes, sir.
Yeah, what type of heterocyclic group is there in your compound?
We have also taken azomethane and isatine and thioproline or sarcosine, but we changed the chalcone. Almost
chalcone,
mechanism.
Okay. You have prepared chalcone,
different type of chalcone. Benzodioxole grafted chalcone. They were having better activity than the control Carbazoles.
So you are working with whom, madam?
For us, anti-diabetic studies were helped by Tumkur University. Swami Srinivasa, one of our collaborator, they are doing all these studies.
Okay, okay.
We will synthesize and characterize and single crystal studies, everything we have completed. The diabetic activity was done by the Mysore people.
Mysore, okay. If suppose, if we, that in our university, that biotech department also, they are taking undertaking,
Okay. Yes, sir.
Biotech.
Yeah.
But they are asking co-authorship,
Oh, that everyone does the same wherever you do.
That problem is there. Yeah, you have to give, because
that is
that our work will not be recognized.
Accepted.
That's why if he helps 2-3 papers, I think we can give one paper.
Yes,
as a bonus.
Yeah, that is also a huge study. They have to do a lot of optimization and other things, which we can't do. So
actually, madam, in our this thing, when we are doing there, when we have done some reaction work on phenylene alkydes, the Prabha, one girl, that was my PhD scholar, one of the scholars.
She is present.
She's present. She has prepared only some few compounds in naphthalene systems. That paper, has actually made Kimcom. Actually, based on that paper, she got the CSIR SRF fellowship. Only one paper. Just she got to that product. That compound is found to have very good anti-cancer property. Naphthalene systems, madam.
Yes, sir.
Okay.
Sir, thank you, sir, for your compliment, sir. I am present.
Prabha?
Sir, I am present, sir. I am here only.
Okay, thank you.
Sir, I thank Professor Sivasanmugam, sir, for arranging this great seminar, sir. Because we are waiting your lecture for a long time, for 6 years. 6 years தான் வந்து வெயிட் பண்ணிட்டே இருக்கோம் சார் உங்களோட லெக்சர் கேட்கறதுக்காக.
Thank you.
Thank you.
Sivasanmugam sir, thank you so much, sir.
Your voice is not so clear. It's not audible very much.
Sir, is it audible now?
Yes, it is audible.
Yeah, I know.
Yes, it is audible. Now you can come.
Guest lecture, sir.
All your students are there.
Any other questions? Any other questions from any participants? Yeah, Anandi has raised her hand.
I'm very thankful to you.
So, can you put it in the chat box? Can you put it in the chat box? Anandi, yes. Can you put your question in the chat box?
If you put it in the chat box, can you please read it? Dr. Monali, can you please read it?
Yes, sir. I have not received any questions so far.
Or Jai Vignesh, anyone? I am unable to read it.
The question has not been received in the chat box. Maybe we can wait for a few minutes.
Anandi is unmuted. Can you check from your end, sir? Can check from your end.
I am unable to read this message. Actually, there is some problem for my chat box.
No.
The professor.
Good evening, ma'am. I raised a hand for the feedback link. In the chat box, not enabling for me. That's why I raised a hand, ma'am.
Okay. It is not enabled for you. Others has filled up the form.
Not enabling for me.
Okay, once again, I'm just including, or otherwise we'll send you tomorrow the feedback.
Those who have
Okay,
not
ma'am.
got the feedback form link, can you please
You are
send me a request so that I can send the link to everyone? Or Dr.
Okay, sir,
Monvili
okay.
or
Thank
Dr. Jai Vignesh will send it.
Can send it to the, you have registered, I hope so. So you can also send through the GPI mail, the feedback form. We will send you the feedback form tomorrow. You can give a
Okay, ma'am, thank you.
request. Thank you.
Me also.
Any other questions? Any other questions? So I don't have any questions in the chat box. Can I close the session, sir? Sir, I
Okay,
don't. Yes.
Dr. Monvili,
Yes, sir.
can you please take over the session and
Yes. Yes.